Hello friends, so in this question block A shown in the figure move by distance 3 meter towards left. So block BA moves toward left by 3 meters and find the distance and direction in which point P on the string as shown in the figure is displaced. So what we do to make a calculation in terms of journal, we assume that let block A moves towards the left by x meters. Okay, later on we can substitute the value of 3, and we also assume that if A moves towards left, B moves by a distance of y, and let us name the string as 1, 2 and 3, and we have two pulleys. Let us name them as x and y. So it is given that block A moves toward left by x. Now block A is connected with pulley 3x, and pulley x is in turn connected with strings 1 and 2, but along with this block A is also connected with string 3. So there are three strings which are associated with block A. So we can say that block A is connected with pulley X and 3 strings. One, 2 and 3. So what happens is that as block A moves towards left, the total slack that will be coming or being associated with block A will be of string 1, 2 and 3. So you can say that therefore total slack associated with block A is because of strings 1, 2 and 3, with each having a slack of x. So this implies that total slack of block A is equal to 3x. Block B is connected with only one pulley, that is y, and it is having two strings connected with 2 and 3. Okay. You can say that block B is connected with pulley y and 2 strings. Two and 3, with each having a slack of y. With each having a slack of y, therefore the total slack that will be associated with block B will be 2y. Thus we can say total slack of block B will be equal to 2y. So let us call this as 1 and this we call equation 2. So if we now we want there should be no slack between block A and block B. Under this condition, equation 1 should be equal to equation 2. So we can write that for no slack between block A and block B, equation 1 should be equal to equation 2. Equation 1 is equal to equation 2, or rather we can say 3x is equal to 2y. Now in this case, we are supposed to find out the distance and direction in which point P moves. Now point P, the distance as well as direction of point P can be found out with respect to block A or with respect to block B. Okay, so we can say that distance and direction of point P can be found out with respect to block A or block B. So if you want to consider block A, okay, so we can say that for block A, point P is connected through pulley X to only two strings, 1 and 2. Okay. For block A, point P is connected to pulley X with two strings, 1 and 2, and each string is having a slack of X, and each string with slack of X. So we can say that thus the slack in point P, thus slack associated with point P will be equal to 2x, and we already know value of x, which is given as 3 meter. So we put the value of x as 3, so we get this as 2 into 3, which will be equal to 6 meter. So point P moves by a distance of 6 meter, and it will be moving towards left 6 meter, and here we can write towards left. And if you want to use block B, it is same. Point P is connected with block B with two strings, 2 and 3, and each having a slack of Y, and we already know the relationship between X and Y. We can use this relationship, substitute the value, and because in the question it's only given that block A moves by 3 meters, so we can find out the displacement of block B. Here from using this equation we can find out Y, and subsequently we can find out the moment, or rather we can say the slack which is associated with point P using block P, which will be the slack of string 2 and string 3, which will be, and substituting the value of y as well as x, and it is going to give the same answer, that is the slack associated with the point P will be 6 meters towards the left side. Thank you.